Welcome back, everyone. Today we're going to start our work on Chapter 9 in conic sections. First question you might have is, what is a conic section? It's not something that you've been presented with, I don't think, so far in your mathematical career. Basically, a conic section comes about when you take a set of cones or a pair of cones stood tip to tip, and you take little cross sections of them at various angles. And depending on which angle you slice at, you'll get a slightly different shape. So some of the shapes you'll recognize, some of them you may not, but we're going to take at least one day on each of these ideas, and we're going to explore the math behind them and learn how to graph them in a two-dimensional plane. This ends up being a pretty important topic in mathematics because a lot of these shapes are very helpful in engineering problems, and they do actually all have some sort of real-life application, and I'll try to highlight those when applicable. This is another representation of the same thing. So if you take all these cross sections and you pretend like there was no solid in the cone, the intersection with the plane with the surface of the cones would make all these five shapes. So you should know circle. Well, you should probably know all these names by now, but circle, ellipse, parabola, hyperbola, and you can actually get a straight line as well. But these are the four that we're going to focus on during this chapter. On our first day, we're going to talk about circles. Circles should be reviewed from Algebra 2 and geometry, but I just want to refresh your memory on how to graph them and how to write an equation for a circle. That's our job today. Firstly, a definition. A circle is the collection of all points that are equidistant from a central location. You may remember that you had a formula that would allow you to graph a circle on a coordinate plane. There's your normal x, there's your normal y, and the only thing that defines how big a circle is its radius. The other piece of information is the location. This is a formula that's centered at the origin, so there's no left or right shift. But if we want a left or right shift on the center, then we just introduce an x left or right and a y up or down shift that we need in order to get the circle where we want it. Here's a couple examples that I've graphed out. While you can't type these equations, see them over here, you can't type those into your graphing calculator because they are not explicitly defined. That is, that y is buried. It's not in function form. It's not just a y equals. There's a y squared buried inside of one side of the equation. While you can't enter it on a graphing calculator, Desmos is well capable. So if you wanted to type these in, try your luck and just see how it works. The orange one right here is centered at 0, so I have one that's centered at 0, 0, and the radius is 3. That's 3 squared would be 9. So it appears as a 9 in the formula, but if you take the square root of it, you'll get a radius of 3. This one's been shifted to the left 5 units. Notice the contradictory sign there. It's a plus 5, but it's really left 5. We've dealt with that before with function transformations here, and this is up 3, even though it's a minus 3 inside the function. Since it's inside the function, it does the opposite of what it says on the tin. And then here's our radius of 4, but we take the square root of 4, and you'll notice that the radius from the center out towards the side or the edge of the circle is 2. So there's really only two pieces of information you need in order to graph a circle, which is the center and a radius. And so long as you know the center and a radius, you can plot the center and go out however far the radius is and go ahead and plot it. At this time, I'd like to try graphing a couple equations. If you want to, make a little coordinate grid on your paper, or you can print this out on the notes. And I just want to walk through graphing one of these. So if you look at the first equation, we're going to do this one in blue. We've got an h value of 2 and a y and a k value of -3. So this is going to be shifted to the right 2 units and up 3 units. So if we move our center there, we're over 2 to the right and down 3. And our radius is going to be the square root of that number right there. So our center is at 2, -3, and our radius is 4. So how we go about graphing one of these by hand anyways, I'm going to go plot the center first. So I go make a dot at the center, and then from this center, I'm going to go out 4 units in the directions that I can feel confident that I can go out 4 units in. So I'm going to go out 4 to the left, 4 to the right, 4 up, 4 down, basically make dots all around that center dot. I can only do 4 of them with high confidence, so from there I think I can sketch in a circle pretty well by hand, and it looks a little something like that. If we do the second one, same deal. This is left 3, up 5, and if we take the square root of 12, it's not going to be a perfect square root, but we can estimate it with a decimal, and go ahead and plot the center again. Move 3.46 or 3.5 units up, down, left, right from that center point, and then try to connect the dots as best you can by hand. The second task you have today is to write an equation for a circle. So there are two questions up on the screen that are slightly challenging for a number of reasons. One, I didn't just come out right and say, okay, the center is here, the radius is here, please write an equation for the circle. I actually gave you slightly more complicated information. So you have to remember, what information do you need in order to write an equation for a circle? Well, you really only need a center and a radius. Here's one. Write an equation for a circle with a center at -4, 1. So there's our center, and a point on the circle, -1, 8. Now that didn't give us a radius straight out, but the distance between those 2 points should give us a radius. Likewise, over here we have a slightly different question. Write an equation of a circle whose diameter terminates at 9, 9 and -3, 7. So basically that gave us 2 points on opposite sides of the circle, but it didn't tell us our center, and it didn't tell us the distance or the radius between them. So in this case, we just have to find a radius. In this case, we got to find quite a few things. We got to find like the halfway point, that'll be our center. We got to find the distance between them and basically chop that in half for our radius. So in order to find this sort of information, you're going to have to dig back to your geometry days, and you're going to have to remember these two formulas. If you don't remember these formulas, you need to have these memorized. These are kind of like a common ACT required prerequisite information that you should just have always memorized. If you don't, take this moment, pause the video, and copy down these two formulas. They are extremely important. The first one will find the distance between any 2 points. So if you want to find the distance between point number 1 and point number 2, it looks an awful lot like the equation for a circle, you might notice. It also looks a little bit like someone solved Pythagorean theorem. They're all related. So there's two very easy ways to try to remember this distance formula. The second formula will find the midway point between two coordinates. This one we don't use as frequently, but it's basically add up and divide by 2. That is, find the average of the x coordinates, and add up and divide by 2 the y coordinates. That is, find the average of the y coordinates. If we have these formulas and we're just aware that they exist, then we can go ahead and start answering one of our questions. So let's start with that first one. Write an equation for a circle with center at -4, 1 and -1, 8. It's not a bad idea to draw a picture, so I did that off to the side here. I plotted our 2 points, and so we've got our center, no big deal. Our h is going to be 4, our k is going to be, or it's going to appear as +4 in our formula. Our k is going to appear as -1 in our formula, but we need to know how far it is from here to there. So I'm going to use that distance formula. So I'm going to take all those numbers that are associated with the coordinates, and I'm going to substitute them in. Be very careful. There will be negatives. There is subtraction in this formula, and there is order of operations. So I want to evaluate this first. So -4 plus 1 would be -3. Square that, you'll get 9. And then I have 1 minus 8, which would be -7. Square that, you get 49. You should always get two positive numbers being added together under the radical, and the radius is the square root of 58. Now I could go figure out what that is as a decimal, or I could try to simplify it in simplest radical form. But to write an equation for this, I know that this is my radius, and I'm going to square my radius in the formula. So I might as well just leave it as a 58. So because the formula itself has r squared at the end of it, I don't have to keep that square root symbol there. Otherwise, they gave us the formula, so that was a -4. Notice that it changes to a +4 in the formula, and we had that +1, which changes to a -1 in the formula. Let's move on to the second question. So this question asks us to write the equation of a circle, but they give us just basically a segment, a diameter. So so we got these 2 points. The circle goes exactly between them. You'll notice that they weren't nice enough to give it on a perfectly horizontal or vertical plane. So we're going to have to do this the hard way. We got to figure out the center, and we got to figure out the radius. So if this is the diameter, we can find the distance between those 2 points, but we're going to have to chop it in half. And to find the center, then we just have to find the midpoint between those two. So if we take a look at this, let's go for the radius first, I guess. Plug in all the numbers. Well, sorry, this one's going to help us find the radius because that'll find the distance between the points, and we just chop that in half. The center is going to use the midpoint formula just by finding the midpoint between the 2 points. And if we sub in the numbers for our distance formula, just like we did before, just be careful with your signage here and your order of operations. We get the square root of 148, which simplifies to 2 times the square root of 37. I did simplify this one just for the fact that I knew I was going to be chopping this in half. So that's the diameter. Chop that in half, and I will have just 1 square root of 37. And then over on the other side, notice that everything's positive here. So we just put in the coordinates as they appear to us. And basically make sure you get your order of operations correctly. From there, evaluate, we get a midpoint of 3, 8, and now I have a radius. I have all the information I need to write an equation for a circle, and plug it into the formula. So that'll be a -3, that'll be a -8, and our square root of 37 gets squared for just a plain old 37 as it appears in the formula. And if we were to graph this, check it out. goes through both points exactly where we need to be, so it looks good. The homework assignment today is going to be the worksheet listed on the website. You're going to do problems number 1 through 3 and 7 through 10 only. You're going to ignore any domain and range prompts unless you want to challenge yourself. And the submission on Schoology is going to ask for your solutions to number 1B, number 1C, number 2B, and number 9. Until next time, I'll see you then.